We can think about the real number line being the horizontal axis, and all real numbers we can fit in on this line include rational numbers and irrational numbers, but imaginary numbers don't fit anywhere on the real number line. So what we can do is we can create a second axis, creating a plane where this axis is the imaginary axis. So these numbers would represent 1i and 2i and 3i and negative 1i and negative 2i, so on and so forth. So using this idea of a plane, let's think about plotting each complex number and finding its absolute value. So the complex number in part A is negative 3i. Negative 3i would be right here. So I'm just going to label this as A because this is the answer for part A. Here it is. And if we think about the absolute value, the way to think about absolute value is the distance from the point to the origin. Well, it's really easy to see here that that distance is just going to be 3. So the absolute value of negative 3i is 3. For part B, we have negative 2 plus 5i. If we want to plot that point, we have negative 2 plus 5i. It's going to be up here. So here is point B. And then if we think about, all right, well, what's that distance going to be from point B to the origin, we can use the idea of the Pythagorean theorem, or this formula right here, the square root of a squared plus b squared, to find that distance. So the absolute value of this number is the square root of a squared plus b squared. Negative 2 squared is 4 and 5 squared is 25, so the square root of 29 is the absolute value. The next complex number, 4 plus I, well, we have 4 as the real part and 1i as the imaginary part, so we can plot point C right here. And again, if we want to think about the absolute value of this number, the absolute value of 4 plus I, we can think about Pythagorean theorem, or the square root of a squared, 4 squared, plus b squared. In this case, b is implied 1, and 4 squared is 16, plus 1 squared is 17, so we've got the square root of 17. And for part D, z equals 1. Well, this complex number doesn't have an imaginary part, it only has a real part, and the real part is 1, so we can plot part D as this point right here. And we don't even have to go through the process of using the formula. We can see that the distance from 0 equals 1. So the absolute value is 1. Let's take another look at this complex plane and think about it in terms of trigonometry. So we've got some point up here, and that is our complex number z, and that z equals a plus bi. We can think about plotting a in the real number direction and b in the imaginary number direction. The distance between this point and the origin is the radius, which is the same as the absolute value. And the angle that it creates is theta. So we can use this triangle to write a couple of formulas. We can think about the cosine of theta being the adjacent over hypotenuse. And we can also think about the sine of theta being the opposite over the hypotenuse. So now, if we want to think about writing this complex number, a plus bi, in trig form, we're just going to use a little bit of substitution. We're going to use z equals, and instead of a, if we solve this equation for a is equal to r cosine theta. So a is equal to r cosine theta. Plus bi. Well, b, again, to write in trig form, we can solve this equation for b, and b would be equal to r sine theta. So b equals r sine theta, and we still have this I, this imaginary number part here. We can simplify this a little bit, and we can factor out an r. So r times cosine theta plus I sine theta. This is the trigonometric form of a complex number. So this is a formula we're going to be using over and over again. I would highly recommend memorizing it. There's a simplified way to write it. Instead of writing out cosine theta plus I sine theta every single time, the simplified way to write this is just CIS. I'm going to call that cis theta. So the complex number in trig form is equal to its radius times cis theta, which means cosine theta plus I sine theta. So I'm going to be using both of these, and this is just a shorthand way of writing the actual formula, which is this. Example 2, we want to write the complex number in trig form. Well, we can use formulas to do that, or we can think about that complex plane again. For I in the imaginary direction, 1, 2, 3, 4, is this point right here. Well, if we want to think about, okay, z equals r cis theta, the radius is the distance from the origin, and the distance from the origin here is clearly 4. Theta is the angle. Well, the angle from starting position to this point right here is the angle pi over 2. So this is an example where we can just plot the point and look at it to figure out the radius and to figure out the angle created. Part B, we can think about plotting. All right, -2 in the real direction and -2 root 3, which is going to be down here somewhere. So here's the point, -2 and -2 root 3. Well, if we want to think about the radius, again, our goal is to write this this complex number, which is in standard form. Our goal is to write it in trig form, which is r cis theta. The radius we can figure out with the idea of Pythagorean theorem, or absolute value. The radius is the square root of a squared plus b squared, which in this case is -2 squared plus -2 root 3 squared. We can simplify that. We've got 4 plus, this would be 4 times 3, or 12. And 4 and 12 is square root of 16, which is 4. So we found the radius to be 4. We also need to figure out the angle. Well, if we label this triangle that we've created, this is -2 and this is -2 root 3, and this is the angle that we want to find. Well, we know the opposite and the adjacent. If we know the opposite and the adjacent, we can use the idea of tangent. So tangent of the angle that we're looking for equals the opposite over adjacent, -2 root 3 over -2. So the tangent of some angle equals root 3. Well, I know because I've memorized these that the angle here, if it was in quadrant 1, it would be pi over 3. So the corresponding angle in quadrant 3, this would be 1, 2, 3, 4 pi over 3. So the angle we're looking for here is 4 pi over 3. And finally, our goal to write our number in trig form, it's z equals r cis theta. I encourage you to use this shorthand notation because it's a lot simpler. When you